Okay, so here we are. We've got a bunch of things we've talked about with radicals, and we need to run through the mechanics of most of them because they really are just skill-based. There's no concept involved at all. So we start with just simplifying radicals in general, which simplifying radicals is all about seeking perfect nths of whatever root you're taking. So in the case of the fourth root of 32x to the 12th, I'm looking for things that are perfect fourths or numbers to the fourth power that I can find underneath that radical. 16 is a perfect fourth. It's 2 to the fourth power. So I can divide 32 into 16 and 2. X to the 12th, if I really think about how my exponent properties work, x to the 12th is the same thing as x cubed to the fourth power. So taking the fourth root of those things where I can, I get 2 from the fourth root of 16. X cubed from the fourth root of x cubed to the fourth, that's all part of an absolute value statement because it came out of an even root, and the fourth root of 2 has to stay under the radical. Now, continuing to think about what I've got, the absolute value of positive 2 is still just 2, so I can rewrite this as 2 times the absolute value of x cubed because x cubed does have the potential to be negative, so it needs to stay inside the absolute value, times the fourth root of 2. Moving over to the cube root of negative 64x to the fifth. Negative 64 is a perfect cube. X to the fifth, we can rewrite it as x cubed and x squared. So we take the perfect cube that is negative 64 and we take the cube root of it. We get negative 4. The cube root of x cubed is x. Negative 4 times x times the cube root of x squared. There's no need for absolute value here because it was an odd root. Now, numbers that are helpful to recognize in the event that we're going to actually be able to simplify these things. We need to be able to recognize things like perfect squares through 25, perfect cubes through 10 cubed, powers of 2, powers of 3, 4, and 5. 2 we should know to the 10th. 3, 4, and 5 to the 5th power, and we'll be pretty good. That's how we simplify radicals.